Okay, so let's start the second lecture with a look at technological revolutions and the revolution that 3D printing or additive manufacturing is a part of. So technological revolutions represent a brief history when a set of technologies is replaced by another set of technologies. These are periods of accelerated technological progress. They're characterized by innovation, application, and diffusion, meaning that technology spreads out across society, making other changes possible, changing other facets of life, of society, and of technology. If we were to look at what a technological revolution is, we would say that a technological revolution should increase productivity and efficiency of work. That is to say, it's going to make us work better and more efficiently, okay, or with less energy expenditure, all right? And when we talk about energy expenditure, of course, we're talking about humans expending energy, but also machines and the energy consumption that goes along with those machines. Technological revolutions always involve not only material change, but also changes in management, learning, social interactions, financing, etc., etc. All right. A technological revolution reshapes culture, society, and even human nature. So it's a very, very big deal. All right. We also need to remember that technological revolutions represent disruption. All right. There's a disruption to society, whether it's good or bad. And in most cases, it's good in the long term, but it's going to be bad. It's going to be felt by different people in different ways, but it's going to be a disruption. All right. There's going to be a lot of shakeup of technology, society, all these things that we talked about: managing, learning, social interactions, financing, so on and so forth. So a technological revolution has two basic features. The first is we can say that it has an interconnectedness and an interdependence of the participating systems. That means that the one thing that sparks the change doesn't just change that one thing. All right. So it has knock-on effect. Think of dominoes, right? When we knock over that first domino, if just that first domino fell and it didn't hit any of the other dominoes that were standing up, then that's not really going to represent a technological revolution, right? But when we have an interconnectedness and an interdependence of a bunch of systems and they start to change, then all those changes are going to take effect, and it's going to have dramatic consequences. The second thing that a technological revolution has to have is it has to have a capacity to transform the economy and the society, right? So it's going to transform how we do work, how we do business, how we live. All right. When you're looking at technological revolutions, and there are many technological revolutions, right? They're not all massive changes to the earth, to society. We have to address whether they are sectoral or universal change. A sectoral change would be a change in a community or in one location, maybe one country, maybe one area of a country. That would be a sectoral change. A universal change would, of course, be a revolution that changes the whole of the globe. Now, of course, this isn't going to happen immediately, right? These changes are like waves crashing over different parts of the land, right? So they're going to come to different areas of the globe at different times based on where they are in the in their own technology, and to a large extent how technology is allowed or able to move from one area to another. Another thing you can try to think of is whether the technological revolution is linear or undulating, right? A linear change, represented here by the broken line, represents a change that is pretty much constant over time, right? It's this change is happening, and it's not wavering. It's not going up and down. There's no plateaus. There's no peaks. As compared to the undulating changes. And this is more of what we, as a society, as a world, expect or experience with large-scale technological revolutions, is more of this undulating framework where we may have a slow build-up to a change, and then there's a very abrupt change where it seems like, wow, where did this come from? And then as people are getting used to that, it plateaus again, and then there's another brief but large scale change. So this undulating change is probably more the norm for a universal change. For maybe some other smaller changes, then we might expect to see a linear or more of a constant change. So if we look back in history, we can identify 7 distinct, large, universal technological revolutions that have occurred historically. Okay, we're going to look at all of these. The first is the agricultural revolution. That's also known as the Neolithic Revolution. Then we have the Renaissance. Then the scientific revolution, followed by the Industrial Revolution. Then the technological revolution, which is also known as the second industrial revolution, right? Following the first. The digital revolution, which we might call the third industrial revolution. And then the information revolution, which is really where we are right now, which is called the fourth industrial revolution. All right. So we're kind of at the point now in time where, the seventh technological revolution is underway. Okay. So looking at each one of these a little bit more in particular, the agricultural revolution is our transition from hunters and gatherers to agriculture or farmers. It occurred around 10,000 BC, and it's characterized by a transition from the use of these hunting tools that we see here to more of the farming tools. And so that's what we see when we look back archaeologically through these sites. We see the hunting tools kind of disappearing, and we see more and more of these farming tools that are used to cultivate, to help farm. The agricultural revolution, therefore, represents the beginning of farming. It also represents the domestication of animals, oxen, cow, goats, pigs, sheep. I think dogs were domesticated earlier because they were more of a assistance to the hunting phase of human life. But certainly the other domesticated animals that we benefit from nowadays, and especially the ones that we get food from. And it also represented a shift from nomadic lifestyle to organized community. So it really was the beginning of cities as well. Okay, so obviously we could say that was a pretty huge change in human life. Moving on to the Renaissance technology revolution, this occurred from the 14th to the 16th century. And we can see some of the representative samples here. This, of course, is Leonardo da Vinci. Some other characterizations of the Renaissance technology, that's where the printing press was developed, right? Or the time that printing press was developed. So we have the advent of we wouldn't call it large scale, but back in those days, it was large scale printing, the ability to print books rather than have monks and special people act as scribes to rewrite books as they were being copied from place to place. We also have linear perspective drawing, Okay, this was a big change, linear perspective drawing. The mechanical clock was invented during this time. And also what we consider now modern architecture, or the drawing of orthographic shapes and the representation of those shapes in construction projects. Okay? Moving on to the scientific revolution. Here we have the revolution going from the 15th to the 18th century. So about 100 years, and that's going to be a theme that we'll see, about 100 years past the Renaissance was the scientific revolution. This time period represented the large developments, the critically important developments in math, physics, astronomy, biology, chemistry, also the scientific method, how we do research, how we make changes to science. Copernicus is this gentleman over here on the left, and he started the period with the publication of On the Revolution of Heavenly Spheres, which was an analysis of basically what's happening in the universe. In the center, of course, is Newton, and his publication of the Principia, which represented the laws of motion, gravitation, and also he's the founder of calculus, which probably a few of you don't appreciate, but nevertheless, that was important. And then finally, this gentleman on the right is Galileo, and he ended the period with the publication of the Dialogue Concerning the Two Chief World Systems. So again, a look at the universe writ large, and really an attempt to understand the world and the universe. And this was the scientific revolution. All right. So then about 100 years after that, we embark on the Industrial Revolution. All right. This is probably the one, maybe because we still have some photos from this period, maybe because we still have some remnants of this period that we can touch and see. But the Industrial Revolution occurred from about the late 1700s to mid 1800s, so 18th century to the 19th century. And this started with the mechanization of the textile industry, right? So textile industry, making shirts and clothing and making rugs and all that stuff with cotton and other types of textiles. That was a very labor intensive manufacturing process, very expensive actually. The weavers back in those days, they were the elite workers, right? They had for that time period, they had very high salaries. They were very well respected, but they kind of pushed their luck too much. And what happened was there was a gentleman who invented the ability to make this yarn or textiles into fabric using a mechanized process, right? He used water power and steam to do this, and that basically changed that part of society, that part of the economy, and it had a knock-on effect, right? Because once you mechanize a certain segment of the industry, in this case the textile industry, there's going to be a knock-on effect because other manufacturers and owners of businesses are going to see those improvements in efficiency and productivity, and they're going to want those for their businesses. So there was a knock-on effect there. We also, during this time period, learned how to make, or not learned how to make, but improved our iron making capacity and procedure. It was probably, some say, the most important event in the history of humanity since the domestication of animals and the agricultural revolution. Okay, so this was a great change that we're still experiencing, and of course, because it's a technological revolution, we still see the benefits from. But there were large-scale disruptions. This is the time period when the Luddites And we're not going to go into that, but I would encourage you to look up the Luddites, Luddites, the Luddites. They were a group of basically weavers, textile workers, that revolted and made a revolution for a short period, trying to undo the mechanization. Of course, they lost, but nevertheless, they made a mark on society for a short period of time. So then we move on from the Industrial Revolution to, and again, you'll note, roughly 100 years, the Technological Revolution, aka the Second Industrial Revolution. So this occurred from the late 1800s to the early 1900s, right? 1870 to 1914, although, these hard dates are a little bit fungible, right? They're a little bit squishy. But the Technological Revolution was a phase of rapid industrialization. So, it kind of takes the first Industrial Revolution, and this is when it really catches fire, okay? It ended with the start of World War I, right? So World War I was basically the breaks, right? World War I occurred right after 1914. And it represents the break to this technological revolution, right? During a world war, of course, we can't be focused on production and manufacturing. One of the great inventions that occurred during the Second Industrial Revolution here was electric power. So before this time, we had water and steam power, right? So all the manufacturing, all the transportation was done through water and steam power, ships, so on and so forth. But the Second Industrial Revolution is where we developed electricity, and we started to have these electrical grids that were running through. And of course, this brought on mass production, okay? The adoption of pre-existing technologies such as the telegraph, railroads, gas and water supply, and sewage system was also refined and updated here. And then, of course, the internal combustion engine, okay? And you can see pictures of all this. This is actually, on the left-hand side, this is a figure from Thomas Edison's patent for the electric light bulb. And I would also challenge you, like with the Luddites, I want you to do a little research on your own here. But this is more of a thought experiment. Think about how society changed from having no light at night to having only gas lamps at night, right? From the first Industrial Revolution to having electric lamps at night, right? Think of how society would change. Think of how you would change, your family would change without any electricity at night. How would things change to having, maybe dimly lit gas-powered lamps, which is what they had by the time of the first Industrial Revolution, gas-powered lamps, or even candles, all the way up to the advent of the electric light bulb. Think of how society changed when we were able to illuminate nighttime inside of our homes, inside of businesses, and outside in the streets. That to me is just a remarkable invention and change in society. Which brings us to the digital revolution. Okay, so this is one of the revolutions, the third Industrial Revolution that I was, of course, around during. Growing up in the 60s and 70s and 80s. This is where computers started to really take hold of society. We changed from an analog and mechanical to an electronic and digital world. All right, think about that. Analog and mechanical to an electronic and digital world. And we can see the changes right now that have taken place because of that. The invention of digital logic circuitry, the computer, the cell phone was invented during this period, and the internet was invented during this period. Personal computing and networks were also developed during this period. So, huge changes, basically to the interconnectedness of modern day life and the economy. Which brings us to the last industrial revolution. Now, this industrial revolution, which we can call the information revolution, or though there are other names for it, we'll talk about some of those later. But the information revolution occurs from basically 1960 on to today. So this technically is the fourth industrial revolution that we're in right now. Okay. It's a growing economic, social, and technological role of information in society, right? Not just data, but information. The growing information sector of the economy is really a dominant force today across the world. Innovations result of production of new information. The growth of the internet is occurring right now, or occurred during this time period. Dissemination of information globally, right? So we're sharing information readily, instantly across the globe, right? So we don't have to mail things and wait for them to arrive. We don't even have to call anymore. We can fax, and we can email, and we can check web pages all over the globe instantaneously. And that's characterized by the sharing of information, right? So the global sense of the economy, right, has really shrunk. The communities across the globe that used to be disparate and distinct and separated, for good or bad, have shrunk now so that we're all much more interconnected with each other. Now, critically, and again, the information revolution, it can also be termed the fourth industrial revolution. Critically, and especially for us in this class, there are 5 technologies that are reshaping, and they're in the middle of reshaping, so we haven't seen the end of this yet, but 5 technologies that are critically reshaping how our economy and how society works. These are 3D printing, or additive manufacturing, nanotechnology, right? The ability to build very, very tiny machines that can be basically injected into your body, into your bloodstream, or machines that operate at the microscopic level. Cloud computing, the Internet of Things, and wireless communication. So if we look at the Industrial Revolution timeline, kind of just focusing on the first, second, third, and fourth, right, we can see maybe a little bit easier, taking a step back, kind of the time scale here. So the 1800s was roughly where we had the first Industrial Revolution. The second Industrial Revolution was basically the 1900s, right? The early to mid 1900s. And then the third Industrial Revolution occurred, according to this chart, from about 1969 on. And then the fourth Industrial Revolution is where we are today. Okay, so this gives you kind of a time scale perspective of this. Okay, but since we are talking about 3D printing and additive manufacturing, let's now focus on that industry or that technological change, and try to get a better sense of how that it has grown over time, over the short period of time when we've had 3D printing and additive manufacturing. So in this chart, we can see world printing demand in millions of dollars. And what I just want to point out, we're not going to go into each one of these numbers, but what I want you to notice always when you look at these is try to notice the trend, try to see the trend. So in North America, we can see the 3D printing demand in dollars in 2007 was $361 million. But look at 2012, now we go to 900, 2017. So this is 5 years. We're up to $2,285 million, or $2.285 billion. And then 5 years later, we're nearly doubling that, right? Nearly doubling that to $5.1 billion, right? And then we can see the annual growth. We have a 20% annual growth. That is phenomenal. That is a huge annual growth rate. Asia Pacific is very similar with a 19.4 annual growth from 2012 to 2007, sorry. And then from 2012 to 2017, 21.3. So you can see they're accelerating. They're actually beating the North American annual growth. If we look at Canada and Mexico, they're also exceeding the North America in general. All right. And Central and South America, again, really booming here. So it's just interesting to see. If we look at the total across the whole globe, right? North America, Asia Pacific, Central and South America, Eastern Europe, Africa, and the Midwest. And we can't exclude Western Europe in there. I don't know why that's not gray, but the total, we go from 775 million to 1.9 billion to 5 billion again. So that's more than a doubling of that. Again, more than a doubling again 5 years later to 2022 and 11.7 billion, representing just a smidge over a 20% annual growth for all those periods. Okay. Now let's look at a chart of the market size for global 3D printing products. Okay, so market size represents how big the market for 3D printing is. That is to say, all the products and services that are being 3D printed or that are used for 3D printing. And again, we can see a pretty substantial growth pattern, right? So from 2020, we had $12.6 billion. All right. This is by the way, this is global, right? Even though we're looking at these numbers in US dollars, this is global. $12.6 billion to 17.4. This is 2 years later, just 2 years later, and we have almost a $5 billion increase. 2 years later from that, $7 billion increase. And then this is 2 years, 2026. Now, of course, these are projections, right? These are projections, but they're projecting a over 10 billion, right? 24.9 to 37.2 is almost 13 billion, $12 billion increase in the market size globally. All right, so that's a huge that's a huge market globally. So if we turn our attention to additive manufacturing production, right? This is making of the additive manufactured parts, right? So we're making 3D printed parts here. Okay. And this is interesting because you can see in the early or in the mid 1990s to early 2000s, look at that. There's not a whole lot going on, right? And we'll talk about this in the next lecture a little bit more, but there's not a lot going on. And then right around 2006, 2008, this is where things really start to grow. And look at that trend right there. We're really growing up past $5 billion, right? This is in millions of dollars. So 5,000 million is $5 billion. So we're shooting past that. And this is 2020. So these are actual numbers, right? This isn't a forecast like in the last one. In the last one where we're forecasting these last three charts. These are actual numbers. Okay. So then we look at final part production. Again, very similar. Right, very similar. Right, we see that increase. It's nice, nice trend line upward. You'll notice here that there is a flattening of the curve, right around here, represented a flattening of the curve in 2020, and that was, of course, weak growth due to the pandemic. Okay. And again, you'll see this one's probably a little bit better. This is unit sales of desktop 3D printers. But again, you'll notice what you're looking at is the increase from one bar to the next. And you'll see right here, it looks like it came down a little bit. It's still increasing, but it's not as high as the other one. So that rate of change, that slope kind of flattened off again. And again, that was due to the relatively weak growth of desktop 3D printers due to the pandemic. Sales grew by 19.4% in 2019. Okay. Unit sales of desktop 3D printers grew by 6.7% to an estimated 753,211 units in 2020. Okay. By the way, when we talk about desktop 3D printers, these are 3D printers that sell for less than $5,000. So, they're like some, not all of the 3D printers that we have in the department, on campus. Definitely, the types of 3D printers that you would find at Micro Center and for sale on Amazon, and maybe the type of 3D printer that you have at home. All right, and now moving on to metal additive manufacturing sales. So this is metal additive manufacturing system sales. So these are companies buying the machines that print in metal, do 3D printing in metal material. And we can see a dramatic rise in metal additive manufacturing sales. Again, we see this undulating kind of meandering, and then this explosion upwards. And notice from 16 to 17, it was really a increase upward in those sales. And like I said, we'll talk about why that increased in the next slide. It had to do with patents, and it had to do with which companies and number of companies that were able to make these metal additive manufacturing machines. And that is the end of our presentations here. Let me go back one more. So that's the end of our presentation here. So I hope you got a little bit more insight into the history of technological revolutions. 3D printing is definitely part of the latest fourth industrial revolution. That's why we're here talking about it. And you can see from the charts that I just showed you that we're still undergoing a dramatic rise in all the factors of 3D printing, both in sales, demand, and in production.